GM everyone. Today we are going to have an engaging session on zkWeb. So we have Sarah, who's a software developer at Amber Code. So she'll be walking us through the code and demo of zkWeb. So feel free to drop your questions in the chat throughout the session, and we'll address them during the Q&A at the end. We encourage you to engage with Sarah during the session and make the most of this opportunity to deep dive into zkWeb. Yeah, over to you, Zara.
Thank you. Yeah, hi everyone. Let me just quickly share my screen here. All right, so yeah, today I'm going to be kind of just walking through a project that I've worked on kind of on the development side of things related to zero knowledge proofs. This may not take the full hour, but we'll see what happens. So a little bit about me. I'm based in Chicago in the USA. I'm a software engineer. I've been working in the blockchain space for over 5 years now. I have also done quite a bit of developer advocacy type work in the Web3 space. So for a long time, I made like educational content and videos on YouTube, technical docs, stuff like that, and went traveling to different conferences and made content. And as you can see in this picture here at ETH Denver, I actually went there to share a little bit about this project, and that was kind of how I initially got connected with the zkMonk organization and some of the team here and got involved doing this. So I got into blockchain in the first place quite a while ago. Back in 2017, I started getting interested in crypto and kind of fell down the rabbit hole on Twitter and ended up deciding that, hey, I think it would be really cool if I could learn about coding and maybe do something more with this. And so I ended up going to a coding bootcamp in 2018, which I feel like for a lot of people, it's sometimes the other way around. They start out kind of already in tech and then move into the Web3 or blockchain space. But for me, it was the fact that I found that stuff so interesting that made me want to learn about and try to do more with tech. So after bootcamp, I went straight to work for a blockchain data analytics startup here in Chicago. Eventually, I joined up with some coworkers from that company, and we started our own company called Genesis Volatility, where I was the Web3 tech lead. So I oversaw all of our systems integration with Web3, its smart contracts, and all of that. And that company was ultimately acquired by Amber Data, which is where I work now. And so I have a little screenshot here. I was interviewed about kind of that whole process and working in Web3 and what that's been like, and being a founder and all of that stuff. But what I mostly do now is working across full stack as an engineer, so ETL processes and data engineering side, all the way to data visualizations and front end in the UI. So that's basically what our company does is we build institutional grade infrastructure so that financial institutions can have access to blockchain data. And so these are some of the platforms that I actively maintain. So, and the projects that I'm about to show you today are a little bit more on like the front end kind of side of development stuff, just sort of like designed to be user-facing applications, basically. So my goals for this presentation, given all of that, is really just to give some inspiration on the development side for the projects that you are all going to be building soon, getting to the build tracks of this course that are coming up. And I know some of you indicated some front-end experience or interest in that, so maybe for those of you, this will be kind of interesting too. And we've gotten to hear a lot in this course so far about kind of the cryptography side of things and like a lot of the math behind circuits and stuff. So this is taking it a little bit more into kind of a software development direction. So hopefully it can kind of show the opportunities you can find if you just build a project. I came into this kind of as just an enthusiast around zk stuff, and have come all the way to this point just because I started kind of tinkering with stuff and building something. So my inspiration for this project that I'm going to show you is called zkWeb, and the name for that I got from the idea of basically just bringing zero-knowledge proofs to the web, essentially. And what gave me the idea to work on this was last year I was doing some freelance development work, and I had a client come to me and ask for a proof of concept in the nonprofit health tech space. And they wanted to basically create something that they could go back to their organization and say, hey, we could build on this more over time, but this shows that it's possible for us to create something where patients and their healthcare providers, they can sort of verify information without having to reveal that to this organization. Was like a third party. And so they were like, let's say a patient has an appointment on a specific date, and we want to be able to verify from both parties that that information is true and that they both know when the appointment is, but they don't necessarily need to reveal that information to us, for example. And so I was kind of working with them on putting together a proof of concept for that. And in doing so, I thought, you know what? There might be a way that I could kind of build a version of this tool that is just a little bit more generic, that other projects and other developers might be able to leverage and use, basically. And so that was where I got the original idea for this project. So I'll just go ahead and show. So this is zkWeb, and it's a pretty basic project. I'll kind of just walk through the little documentation that I have for it really quick, and then show you how it works, go through the flow, and then show the code. But basically, this is designed to be very beginner friendly. So, you know, for people who are just beginning to get interested into zero knowledge proofs, or developers who haven't worked with it much yet and are curious, that was kind of my goal when making this. So a lot of this initial stuff is kind of just, you know, really simple level, like what are zero knowledge proofs? Like, why does this matter type of stuff. But basically what this app allows you to do is create a proof based on any secret key. So you enter some text or file or data, and it generates a proof, which is, well, I gotta go back, which will be one of these little things here. And then anyone can come and find that proof and click on it and enter the same exact message that you entered and hit prove, and show that they know the correct key without revealing to anyone what the key is, basically. So really basic concept, and I'll show that in a second. But how it works from a high level is that you come create a proof as the verifier. You give it a name so it's easy to identify and search for later. You can do image-based proofs, so you could upload an image. You can also do text, and you can input a date. Because originally when I was building this, it was like patient appointment dates and stuff like that. So it made sense to just have those as the options. So all the proofs that are generated using zkWeb are public. Anybody can submit a key for validation, and the key itself is not stored anywhere, only the actual proof that it generates. And after you successfully generate the proof, you get presented with the prover URL, so you can share it, you can save it, whatever. Then someone else can come and visit that URL, enter the message associated with the proof, and if the entered key matches the verifier's secret key exactly, then it's a correct match, and the app sends out an email notification to both of you. Hey, somebody just submitted a correct key to your proof, and the email address that you provided. So, and it has to be a fully exact match. So obviously, you know, even one character difference in the key, it's not going to find a match. I also left the endpoint for the API side as public. So if you came and created a proof on this app and then wanted to programmatically take input and check against that proof if it's correct from your own app, I left that open for like other people to be able to use. There's some information about that. On the technical side, and I'll go into this a little bit more when I show the code, but the core functionality of zkWeb is built using Socrates.js, which is basically a toolbox for zk snarks on Ethereum. So it helps you create off-chain programs and then link them to the Ethereum blockchain using JavaScript bindings. And Socrates is, as I came to learn, a little bit of kind of an older tool in the space, and it does have some limitations. So we'll get to it. There's a version of this project that I'm working on using other tooling and updating it. But initially, this was the way that I built it. So the things that I did kind of like about Socrates is that it's pretty, the steps are pretty broken down. So you can really kind of see exactly what's going on at each point in like the compilation process. And they do have like, their documentation is pretty thorough and pretty clear, I felt like. So worth checking out if you're a JavaScript developer specifically. But the way it works is that when a verifier first submits a key to generate a new proof, that key gets sent to the API as a string. If it's an image, we take the base URL. And then a unique cryptographic hex hash is then generated from that string. And right now, Socrates.js is limited to 14 digits. So we had to just take that as the longest string of numbers that can be accommodated. But the more digits that could be used, obviously, the more collision proof we would be able to make the hashing. So that's one limitation. But it's a SHA-256 hash and then a 14-digit substring taken from the hash. And then we initialize Socrates.js, which actually uses like actual Solidity code that you pass into Socrates and it compiles it. So we have a circuit that's designed to return true or false for matching input. And then we pass the hashed input value into the Socrates.js compute witness method along with our compiled Solidity code, and it generates a witness that can be used to create a proof. And that compilation output includes an array of 228-bit integers that represent the input that was sent. So then we have some magic because those are pretty big numbers for JavaScript to handle, which is another limitation of that tech stack choice. So that part gets a little bit hacky, which I'll show, but it does work. Those segments get passed into the Solidity code, which is then recompiled, so the program will only return true for the specific matching input that was sent. And from that, Socrates generates a verification key pair, which we store in the zkWeb database along with the proof. And then when a prover submits, when somebody else comes and submits a key to your proof, the whole same process is followed. We hash the input, pass it into Socrates to generate a proof. And then we grab the original proof from the database and we pass in the inputs array from the inputs that were just sent in by the prover. We replace those inputs and that was just computed for the prover's key. And then that is passed into the verify method for Socrates along with the original, with the verification key from the original proof. So Socrates will return a response of true if the provided key input matches, and false if it does not. So already some obvious improvements. Making the input hashing further collision resistant would be great through better solutions like more salting or hash chaining. And then I thought it could also be cool if we had the compiled Solidity smart contract code be programmatically deployable to the blockchain as well. So that's kind of an overview, but I'll go ahead and just show what this looks like. So if we wanted to just generate a new proof, we'll just say, and I'll put in my email. And then we'll make the secret key just something like zkMonk summer bootcamp and generate. And so it does take a little bit of time as well. It's not super fast. Doing it this way with JavaScript and using Socrates, which is another limitation of it. So it does take a couple of minutes to process and do all of this. But what else was I going to add about this? Oh, yeah. So obviously, just putting in any random text and having someone else prove that they know it, not necessarily the most useful thing in and of itself, right? This was just, again, originally kind of built as like a proof of concept for something else. However, the goal was to kind of expand on what this could potentially do, into maybe, you upload like a data set and people can prove that their data set does or does not include certain things. So you can show that you have unbiased data or something like that. So that was kind of like my thought of where to go with it further. Anyways, so the proof was successfully generated. So here's the URL where we can find it. We also can just return to home and we can see our proof is right here now in the list of proofs. So now I could just be anybody who could come here and find this. I could also search for it if it wasn't showing up in the list. And then again, I'll just put this in. And then we have to provide the exact key that we just did. So let's say that I put in like, what did I say? Summer bootcamp, but I'll leave off the exclamation point and try to prove it. It's going to fail because we won't get a true match returned from the Socrates verify function because the input isn't exactly the same. So again, we'll have a little bit of time to wait and see that in action, but I guess kind of, there we go. So as we can see, the key we submitted did not match the proof. So we'll try again. And that was only, let's see, this should be the correct one if I spelled everything right. That was only leaving off one tiny character. It's not going to work. So it does have to be an exact match. While we wait for that, I can kind of start walking through what the actual code looks like for this project. So here is the screen, the code for the verifier screen. So when you first come and fill out the form for what you want to generate a proof for, all it is just collects the input and sending it to an endpoint. So, if it's an image, we're taking the base URL. So we're grabbing all of that here. Then we're sending it to the endpoint API/generate. And then over here, yep, we submitted the correct proof. So the key is submitted, match the verifier's proof. So we have an email confirming that. So that's kind of, you can see it in action. But the code for that is, so we're basically, you input the secret key and it gets sent to this endpoint here. And what this endpoint does is it first, like we talked about, it takes the input data that we sent and it generates a 14-digit hash from the string. So that function is here in this file. So you can kind of see the step-by-step.
Oh, can I just say something? Your screen isn't changing. We're still looking at the website.
Oh, okay. Sorry about that. Thanks for pointing that out, though. Oh, yeah, let me just, there, make it a little bit bigger. Okay, so yeah, so kind of going back, so this is the endpoint to where the data gets sent from the form, the input from the form. And like we talked about in the docs, the first step is it gets generated this 14-digit hash from the string. So that function is right here. So you can kind of see like step by step how we're doing that in this function. And again, like having to ensure the 14-digit decimal limit due to Socrates not being able to handle larger numbers. Also have to like do some conversions because we have to like convert to big int type that can be handled by JavaScript and then convert it back to a string in order to pass it into Socrates. So in order to like do the calculations and then use a modulus in order to make sure that we don't get more decimals than Socrates can handle and then convert back to a string. So that's step one. Then the next step is it's calling this generate proof function, and that happens here in the Socrates service file, which is where a lot of the core functionality of this project lives. So you can see kind of how many steps it really takes to get this Socrates thing to to fully do its thing. But like we said, it takes actual Solidity code. So this is like the actual circuit for returning matching input. And you literally put that in as a string. So I wrote that first in Remix in the browser IDE, and then made sure that it was like working code by itself and then put it in here as a string. And then we compile that and get a witness that can be used to generate a proof. And then we take the computation output, and this is where the part gets a little bit of a hacky solution because of JavaScript. So when you convert a string to a number using JavaScript, it automatically removes leading zeros since they don't change the actual value of the number. But in this case, we need to have all of those digits because we're going to be putting them all back together when we pass them into the smart contract code, basically. So I had to do some ugliness with regex basically to like handle if one of the account for any substrings that start with a 0 basically by multiplying. If that's the case, then multiply the previous segment by 10 so that we still have a 0 in the string. It just comes at the end of the previous grouping of numbers and not at the beginning where it'll get cut off of the next group. So that's a little bit of unpleasantness to kind of read through in the code, but it does work. And then ultimately each one of those segments gets dynamically passed in right here into the assertion. And so, yeah, that's basically how I did it. And then Socrates generates the proof from this. So we had to split that out into, for the second part of the computation, into another function so that I could redeclare all of the block scoped variables, because the naming does matter as well with Socrates. And so this is where it computes the witness and the key pair using the actual input that we gave it. And then it's just going to return that proof and key pair, which we then can store in the database, this chunk here. So the name that we gave it in the form, the email, and then the proof and verification key pair that we generated. So I have a table in Supabase. This is like all the things that people have come and created out here. People have used it for like payment notification and like hackathon stuff and everything, which I think is kind of cool. But this is basically what it looks like. The output is there, each proof has an ID, and then the name and email, and then the proof and verification key are just fully stored as an entire JSON blob for each row. And so that basically is, then you have a new proof created. If we come back over to the, wherever the main, where's my main page? I think it's like index something maybe. I forgot where, it's been a while since I've worked on this version of the code, so I have to remember where my home page is. But anyway, it's it basically just then represents that in the UI as one of these, and like puts the date that it was created and everything. And then the same thing takes place for the prove route. So once you come to one of these proofs and you put in what you think the key is, then same process, it hits this route and generates the 14-digit hash, or the input that you gave it, does the whole generate proof process in the Socrates service. And then for the prove, it takes the it grabs the proof from the database by its ID that you wanted to prove. So if you're like, I want to prove the key for this one, then it's going to grab from the database the ID that matches that one. It's going to grab the proof and verification key, and it's going to send that to the verify function, which is also in the Socrates service file. And this function has a lot less happening in it, as you can see. But we basically pass into this function the verification key pair and the proof that we just grabbed from the database. And then we pass the inputs array from the input that was just passed in by the user. So the only reason why we run this whole thing again, this to generate the proof for the user's input, is just because we need to get this inputs array, those 228-bit integer array. That's literally the whole reason for doing that. So then we take the inputs array that was just passed in, and we add that right here and pass that into the Socrates verify function with the verification key and the proof from the original proof. And so if the inputs array doesn't match the original one, then the proof isn't going to be valid and it's going to fail. If it's exactly the same, then it'll return true. So all we have to use is the verify method that comes from Socrates, and all of the rest of that logic of checking if it matches is handled behind the scenes, which is kind of nice. So that's basically all there is to this project. It took a decent amount of time to do all of this still. I probably spent like 50 hours on it But it has some limitations. So kind of coming back to this here. Again, there isn't a whole lot of point to just doing entry matching. It was more of just like a developer learning tool kind of thing, proof of concept type of idea. But because of the way that this is built and the dependency on older and less clean technologies like Socrates, it can't really easily scale to better use cases in the way that it's currently designed. So what ended up happening was that I got a starter grant from Mina Protocol to work on creating a new version of this project that uses Mina's technology stack. And then from there, to potentially continue on to implement more useful functionality. So if you're not familiar with Mina Protocol, it's a blockchain project. They're a layer 1 protocol that basically replaces the blockchain with zero knowledge proofs, and it drastically reduces the amount of data that nodes need to download. So instead of downloading the entire or verifying the entire chain from the beginning of time, network participants can just verify transactions using zk snarks, and so nodes only need to store just the small proof. So that's basically what Mina Protocol is. Along with that, they have a bunch of developer tools for working with zero knowledge proofs and for building zk apps on the Mina blockchain. So one of the key things they have is the O1JS TypeScript library, which basically this is an example of that they give of the TypeScript code that you might write with O1JS. So you can kind of get an idea of, something like they have built-in methods like assert equals and stuff that makes, that whole Solidity code circuit assertion that I had in there to assert the equal match, you can break that down into like a lot smaller, a lot easier, cleaner syntax, basically. So O1JS is basically a general purpose ZK framework that gives you tools to be able to create ZK proofs, ZK programs using those built-in provable operations. And a big advantage is that the O1JS framework lets you write apps on Mina that execute, essentially the smart contracts execute client side, which is I should have mentioned, but is another kind of disadvantage or limitation with the existing version of zkWeb, because if you noticed, this hashing, the 14-digit hash, is taking place technically on the server side. This is a Next.js project, and this is technically a server-side file. I could also try to move more of this to the front end to help, or to the client side to help a little bit with that. But the reason why all of this happens on the server side is because it was very slow. Like trying to run Socrates in the browser, like any of this stuff, as you saw, it already takes a couple of minutes as it is in order for it to generate these proofs and do all of this. But trying to do that in the browser, it was taking like 10 minutes and timing out. It's not meant to run on the client side. But obviously that is slightly less privacy. Doesn't really matter here because it's not super serious, right? No one's sending like crazy private information. But for the spirit of correctness, ideally, you want to have this take place on the client side for better privacy, so you're not sending information to the server side. So that is something that Mina has makes it like easy to not have to worry about that. Basically, it's kind of taken care of for you by the way that their tech stack is designed. So I've started rebuilding the project. This is running in localhost because this is not deployed anywhere yet because it's still very much in progress right now. But you can see the design is a little bit more, you know, kind of the style of Mina, because I'm using some of their built-in UI components and stuff for their ZK apps. I can't really demo this yet because it's not fully working. But what's nice about this is that all that we'll have to store is going to be the transaction hash for each one of these. So instead of having to store like the way it is now with these whole like JSON blobs with the whole proof, it'll just be like the hash of that transaction on the blockchain, and we can interact with the smart contract on Mina protocol directly. So that's step one, is kind of re-implementing the existing functionality using this tech stack. So just to kind of quickly show what the code looks like for this and how it's different. So this is the smart contract for matching. So already, like right away, we can see it's a lot more simple and readable than the huge Socrates service file that we had before. So as far as the actual matching part, it's pretty simple, and it's a lot more bug proof because there's not, you know, weird workarounds going on with JavaScript. So you can, this just uses their O1.js TypeScript syntax to write smart contracts. So pretty straightforward. The one thing that you do have to think about with building with this tech stack is like there is a fair amount of boilerplate code. So like the ZK app worker and ZK app worker client, this is just like boilerplate that you have to add into your project basically in order to like deploy the smart contract that you created and be able to access the methods to interact with it and stuff. So you do have to, I have been having to play around with that part of it a little bit, but it is much easier if we look at, so here is the homepage file basically. And if we look in the, where's the like send transaction button? Here we go. Right here, like the user can just enter their secret key, hit send transaction, and that is just all handled right here then to actually like create a transaction that uses the smart contract on the Mina blockchain to see if the input that was just put in is correct, matching the smart contract that we created or not. So that can all be handled like right here in the client, as you can see. And right now I've just been like testing it on their DevNet and whatever. That does also mean this, in this case, we have a hard-coded correct secret key. So rather than someone coming along and putting in a secret key and generating a proof, and then other people seeing if they can guess the correct secret or whatever, this, we just have one predefined secret, and all of these are proving that they know that one secret. And the reason I started with it that way is because I think that going forward, like I mentioned, the goal would be to, you know, maybe have predefined parameters, and, you know, people might upload like a data set or something and be able to prove if it does or doesn't meet those parameters. So I felt like that was kind of the new direction I wanted to go with it. But again, still something that is a work in progress. There is also, I've started down this path with Mina, but there are other options for tools that I'm still interested in checking out. I know one of those is Risk Zero actually has something basically exactly this right here. Prove the contents of entries in a JSON file while keeping all the rest of the data private. They basically have like a pretty built out version already of that right here, which I think is pretty interesting, but it is using Rust, which is like the one slight downside for me because I haven't done as much work in Rust. So I guess the point is lots of tools and options are out there, depending on what type of languages and tools you like to work with. And yeah, that's pretty much it. Hopefully it gives you some kind of an idea of maybe some inspiration or things you could think about that you might want to build for your own projects. Or if you want to help me out on and build this, it's all, I can share the GitHub code is all like open source and stuff, so anyone can feel free to check it out and read through it, or open a PR if you think of a cool feature. But yeah, I guess if anyone has any questions, I'm happy to try to answer.
If you have any questions, feel free to drop it in the chat. Can you please share the GitHub link?
Yes, I definitely will do that.
And we have one more question. What other use cases do you envision for zkWeb?
Yeah, so the main use case that I have been working towards so far is like data verification. So like someone being able to, we can share this after in the Discord too, but I'll just drop the repo link in chat as well. Yeah, like someone being able to upload a data set and have it validate against a zero knowledge proof in a smart contract that proves that their data set does or does not contain certain information, maybe something that people would find useful, like, hey, this is data that my company used to train our AI models for XYZ. And we used private data for this that we can't show you what the actual data is, but just so you know, we can prove that we did in fact have accurate information about the health data that we used for this. We were able to verify that it did contain certain criteria that makes it valid. Or we used a sample of data from a diverse group of people in order to train this model, and we can prove that without revealing who we used, we can prove that we did meet certain diversity criteria. Like something like that, I think could be super interesting. So that's kind of like the main use case that I'm working towards, but I definitely could also see potential for expanding on how it can be used by developers, just like as a developer tool, how we can make developing ZK apps easier and more accessible. I feel like in my experience, when I have given talks or made content or whatever around this topic for developers, a lot of them are kind of intimidated by this stuff because it seems really complicated and hard to understand. And I definitely get that, but I think it doesn't always have to be as hard as it seems. And so I would love for like any ways that zkWeb can make just kind of improve education around this, or just make the whole concept more accessible and kind of help more developers understand why this is cool and why it matters. I think anything around that, I think would be a fun use case as well. Anything else?
Do we have any more questions? I think.
Otherwise, if I just explained everything so well, then that's cool too.
Yeah, I think that's a great presentation. Thank you, Sarah, for walking us through zkWeb, and I think we have gained valuable insights into its functionalities and how to apply it in our projects as well. Big thanks to everyone for joining in, and hope everyone have a great day. Thank you so much, everyone. See you in the next session.
Yeah, thanks everybody.